Okay, this is workbook 4.2. And so we're going to go through here. So this one's about arithmetic sequences, or you could say arithmetic sequences. These are when you add or subtract something every time in the sequence. So you can click on the word, and it'll also give you that definition. So you're adding something or subtracting something every time. So let's just look at this example right here. So 5, 8, 11, 14. I think we did this one in the previous lesson. We're adding 3 every time. Adding 3, adding 3. So it's not something more complicated like add 3 multiply by 2. It's just either adding or subtracting. Okay, so here's a little table that shows you some arithmetic sequences and some that aren't. So let's see what we're doing here. From 5 to 2, we're subtracting 3. From 2 to -1, subtracting 3. -1 to 4, -4, subtracting 3. So because we're subtracting something every single time, the same thing, that's an arithmetic sequence. Same with this one. It looks like we're adding 2, adding 2, adding 2. That means it's an arithmetic sequence. Here we're adding 5, adding 5, adding 5, adding 5. So arithmetic sequence. Now some over here, these are not arithmetic sequences. So to get from 1 to 2, I would add 1. But to get from 2 to 4, I don't add 1. And to get to 4 to 8, I don't add 1. I'm not adding the same thing every time. So that's not an arithmetic sequence. Same thing here, to get from 1 to -1. Well, that would not be, like that would be subtracting 2. And then to get from -1 to 1, it's not subtracting 2. So these ones don't follow the arithmetic sequence patterns. Okay, so let's look at this example here. Sue puts $5 in a coin bank, and each week she adds an additional $5. Write a rule for this sequence and use it to find out how much Sue has saved on the 8th week. Okay, so they wrote it as a function for you, 5n plus 5. So the n is like how many weeks she's saving. So she started by putting $5 in the coin bank. That was like her initial starting spot. That's why there's this plus 5 here, because on week 0, she would have $5. I'm going to write this on my notes page over here, and then I'll switch my screen. And we're trying to figure out the 8th week. Okay. So here's this one right here. So we want to figure out the 8th week. So we can make like a table, or you can write it as ordered pairs. So on week 0, if I plugged in 0 here, 5 times 0 is 0, plus 5 is 5. So before she even started, she had $5. Then we know on week 1, if I plug in 1, 5 times 1 is 5, plus 5 is 10. So the next week she had 10. And we can continue this pattern all the way to that 8th week. So I would have $5 more every week. I'm just adding $5. So on the 8th week, I have $45. And it looks like they also did a little graph of that. So they graphed each ordered pair. So like on our table, we had this 1, 10 right here on our table. After 1 week, she had 10. After 2 weeks, 15. They use these as ordered pairs to graph them. So that's what they did there. Okay, so typically the graph of a linear function is a line, but the graph of an arithmetic sequence is not, because the domain is restricted to natural numbers. So what that means is you can't actually connect these points, because when you connect them, that means that everything in between this dot and this dot also is on the line, like fractions and decimals in there, and that's not true for a sequence. It's just these dots, just the dots right here. So don't connect that with a line is what that part's trying to tell you. Okay. In the following table, find the common difference for each sequence in the column on the left and explain why each sequence on the right is not an arithmetic sequence. Okay, so over here, we want to figure out what's going on. So what they're doing is they're multiplying the number by 2 and then adding 1 and then multiplying the entire thing by 3. Okay, so in the left, the common difference for this one is 6. The common difference for the next one is -1/4, and the common difference for the last one is 5. So to find the common difference, you're looking at what is happening to n every time. And the reason this first one is 6 is because 3 times 2, if I did the distributive property there, 3 times 2 is 6. In the right-hand column, you notice all of these have exponents. We don't want exponents for arithmetic sequences. We'll get to these later in a different type of sequence, but for right now, if you see an exponent, that's not going to be an arithmetic sequence. All right, let's look at the step-by-step. Okay, determine whether sequence A and sequence B are arithmetic. Remember, that means we're adding or subtracting the same thing every time. So from 19 to 12, I'm subtracting 7. From 12 to 5, that's subtracting 7. From 5 to -2, that's subtracting 7. So every time here, I'm subtracting 7. So to me, it looks like sequence A is correct. It's subtracting 7. So find the pattern for the terms in sequence A. I'm saying it's subtracting 7. And they agree with me. So is sequence A an arithmetic sequence? Since it's subtracting 7 every time, we're going to say, yes, it is. And they said yes also. Okay, so now sequence B. Is this an arithmetic sequence? So to get from 3 to 5, I'm adding 2. From 5 to 9, I'm adding 4. And from 9 to 15, I'm adding 6. I'm not adding the same thing every time. Yes, I'm adding every time, but not the same thing. So this is not an arithmetic sequence. But they want us to figure out what the pattern is. So it looks like I'm adding 2 and then 4 and then 6. So let's see what they have to say about that. Yep, so each time the difference is greater than the previous difference. The first difference was 2, then 4, then 6. So is sequence B an arithmetic sequence? We just said no, because it doesn't add the same thing every time. And that's what they said, no. So now you're ready to complete some problems on your own. So what they're going to ask you on this workbook is to determine if something's an arithmetic sequence or not. Are they adding or subtracting the same thing every time? So go ahead and try that one now.